Hi everyone. So we'll start. So we'll be talking about Rook storage for Kubernetes, and I am Subham Rai. Right in the bottom of the list, I am one of the maintainer of Rook, and this is our agenda. We'll be first talking about introduction to Rook and Ceph, where we'll be talking about what is Rook, why Rook, and what is Ceph, and why to use Ceph, and the advantages we get with Ceph. And then I'll be covering on about new features that we are adding or those are in roadmap. Then we'll be talking about Ceph CSI Driver, object storage, and cluster maintenance. So yeah, the first question everyone should be having is what is Rook? So in the image you can see in the center you have a Rook as a Kubernetes operator, which automates Ceph storage for you. And in the top you can see it uses CRDs for deploying and upgrading your cluster. And in the left bottom you can see it uses CSI drivers, Ceph CSI driver for managing your volume and mounting PVCs and all. And in the right bottom, you can see Rook Ceph is a open source project, and it got graduated. It is a CNCF graduate project, and if I remember, it got graduated in October 2020. And it is a community-driven project. We have a good upstream user, and we get good number of contribution from upstream. And it is Apache 2 license. So this is how Rook architecture looks like. In the bottom red, those are Ceph pods, and Ceph is a data layer where your actual data is being stored. And on top of that, we have Ceph CSI driver that dynamically provision and mount the storage to the user application pods. And on the top, you'll see in the blue chart, in the blue color, we have Rook, which is again our operator that deploys and manages the Ceph lifecycle. And coming to why Ceph. So again, Ceph is open source, a distributed storage platform. Ceph is feature rich, and it ticks all the box for real. And what does I mean like tick all the box for real? Is it provides all three kind of storage. For block, it has RBD. For file system, it has CFFS, and for object, it has RGW. So what advantages we get from Ceph? So Ceph is designed to scale out and scale up without any downtime, and it supports thin provisioning. So like you don't have to think or worry about adding adding storage to PVC. It adds storage independent of PVC. And to prove the data, recently we had one of the upstream clusters which had in multiple petabytes of data in production, having 250 nodes and more than like 1800 OSDs. And again, OSDs are Ceph pods that store your actual data. And in the booth, we got lots of question regarding Ceph performance and how to configure it properly. So Ceph is fast when configured properly, and from upstream we have a great blog where someone from the community is getting 1 terabytes of IOPS. So you can read this blog. You'll see how to configure, how the user has configured his cluster to get the better performance and better IOPS. And Rook can be installed anywhere. You can run Kubernetes. Uh, by that I mean whether it can be any cloud, or it can be bare metal or on-premise, and it can also be hybrid. So like you can have a multiple cloud, and you can also integrate your bare metal. So when as a user you deploy, you have data in cloud, you have some challenges in terms of like having fear of data loss, and Rook helps in this case by Rook Ceph helps in this case by replicating your data and distributing or spreading your data across multiple availability zone or failure domains. It also solves problem of having limited number of PVC per node and having poor performance for smaller PVCs. As I mentioned in previous slides, Ceph is does unlimited scaling. You can scale out, scale up dynamically without any downtime. And it also, as I mentioned previously, it also supports for multiple cloud and bare metal support. It can be hybrid too. And we have something called external cluster. So let's say if someone is already having a Ceph cluster running, but they want Rook to manage their Ceph cluster, what they can do is they can plug in the external Ceph cluster, what we say, to and connect with Rook operator, and Rook will manage their Ceph cluster. And one Ceph cluster can be connected with multiple Kubernetes cluster. Coming to new features in 1.17 Rook release, which happened April this year, we added experimental support for CSI driver. Rakshith and Nikhil will be talking more about the CSI driver. We added support for Ceph CSI version 3.14, and we added advanced configuration setting for OBCs, which Deepika and Nitin will be talking about in details. And we also added support for having external mons for two data center scenarios. And in upcoming Rook release 1.18, which is planned to be in August, we are planning to enable the CSI operator by default. Again, it is a stretch goal. And adding support for CSI driver, Ceph CSI 3.15, and adding support for Ceph Tentacle version 20. And we're adding a feature for security patch, not a patch, but to rotate your CSI keyring. Not only CSI, but Ceph and CSI both keyrings. Keyrings are something which are internal to Ceph. So it is something like security feature that we are adding, and we are also planning sometime soon to support NVMe over Fabric. And release-wise, Rook puts their their images and Helm chart in Docker, GitHub, and QA. So yeah, now CSI Dev Rakshith will.
Hi guys, so I'm Rakshith. I'm a Ceph CSI driver maintainer. So we'll be talking about Ceph CSI drivers which we have. So Ceph CSI project itself hosts like three separate CSI drivers. So our CSI driver basically stands as a bridge between the Kubernetes layer and your storage. So in this case, we have three drivers: RBDs, FFS, and NFS. So each one, when you get when you want a PVC of a particular size, of a particular variant, it's FCSI drivers, the one which goes back to the cluster, talks, and then provisions is for you. And also like mounts, snapshots, etc. We'll go through the features. So this is how our generic FCSI driver deployment looks like. So you have a controller plugin deployment, which is the provisioner. There'll be two pods running, but with leader election, only one will be enabled at a time. It will take care of volume creation, snapshotting, group snapshot, and deletion, as well as like volume expansion. There's also the node plugin daemon set, which runs one per node, which takes care of mounting and unmounting per node. So coming to the key features of Ceph CSI driver, which makes it unique, is that we extensively use Rados OMAP from Ceph for state and checkpointing. So we store the metadata regarding a PVC in that, so that we can make use of it later. And also during any kind of process like volume creation, expansion, deletion, or snapshotting, we kind of like checkpoint each process so that it's Kubernetes. A pod can be restarted anytime. So even if there is a restart, CSI driver will be able to get back to its proper state and then continue the process or roll back and start afresh. We also make use of Go Ceph bindings, basically Go bindings for the Ceph APIs. This is mainly for performance needs. Like once a connection is opened with the Ceph cluster, it is reused for multiple calls, so that we don't have to like reopen the connection each time we need to make a call to Ceph, which is often. And also we support connecting to multiple Ceph clusters. So you just need to give us the mon IPs, the secrets, And like the Rados namespace or subvolume group, we want us to like connect to and provision the volumes from, and we'll take care of it. So you just need one single Ceph CSI driver deployment to take care of like multiple clusters as well as Rados namespaces, pools, subvolumes, file systems, and subvolume groups. Thin provisions or provisioning, all the volumes are thin provision. So even if you provision 100 GB, it will not actually occupy like 100 GB in the backend, but as you fill up the data, it also starts filling up. So with RBD, we get read write many in block mode, mainly used for VMs with KubeVirt and other similar workloads where the user application takes care of memory locking. And then we also saw Ceph takes care of like creating and mounting a file system on top of the block device. This is generally recommended for RWO file system use case. And we have CephFX where you need read write many file system mode, and we have NFS, which is basically NFS export of CephFS. So through NFS Ganesha, mostly in case you need to like export your storage and consume it from external clients, which supports NFS rather than CephFS. So coming to the features, we have quite a lot. So we have PVC encryption enabled for RBD and CephFS. We have integrations with various key management services, which will store your encryption keys like Vault, Azure, IBM, HPCS, and KMIP. Yeah, you can check the projects for the latest supported KMS. We these are the most stable functionalities like expansions, cloning, snapshot. Group snapshot is pretty new, but we've done it a lot. So like yeah, group snapshot can be considered stable as well. And we have ROX clones, that is read write many shallow clones. This is particularly applicable to CephFS, where cloning is actual copies, so it takes a lot of time. So we just mount the snapshot in when you create a read write many PVC from a snapshot, you basically can mount the snapshot itself instead of creating a clone and then mounting it. This is the internet for backup purposes where you take frequent snapshots and restore it and take backups. And the next one is a very new feature, change block tracking support for RBD PVCs. So this is for backup vendors who need to like efficiently backup your data. So with this particular feature, change block tracking, you can see like there are a snapshot level changes in a RBD image, and it gives you the offsets and the length of bytes change. So the data vendor can, like backup vendor, can just back up these portions. And we also have self-recovery capabilities within Ceph CSI. So if your particular node goes down in Kubernetes, Ceph CSI can take care of like making sure that particular image or subvolume is disconnected from the cluster, and your app moves conveniently to the next node as soon as possible. And read affinity is a feature where if you do a read from a volume from a particular node, and the read is served from the nearest OSD in the cluster. We have static provisioning, where if you have your already provisioned or like created images of subvolume, CephCSI can go and mount it in your Kubernetes clusters as well. We have support for kernel clients, that is KRBD and CephFS kernel client, and user space clients as well, RBD, NBD if you want more features, and Ceph Coming to CSI add-ons, my friend Nikhil will be taking on. Thanks.
Okay, so hi everyone, this is Nikhil. I work as a software developer at IBM. So let's discuss what is CSI add-ons. CSI add-ons is basically an extension to the Kubernetes CSI interface that we have. It comprises of 3 different components. Let's discuss what the components are. As you can see, there is a CSI add-ons controller, which is more, you can say, as an operator, which contains a set of controllers for managing the different operations. Then there is a CSI add-ons sidecar, which runs alongside the CSI driver as a container, which interacts with the CSI operator through gRPC. And whatever operations are executed on the Kubernetes cluster can be relayed that to the Ceph cluster through the CSI driver that we have. So let's move ahead to the set of operations that CSI add-ons provide in addition to the CSI interface that we already have. Starting with the reclaim space operation. The reclaim space operation basically executes RBD sparsify or FSTrim on images that are mounted as file system, which basically helps the user to get the actual consumption of the data on the cluster, because it sometimes might happen that the data is cleared out, but there are chunks left from the older data, which might still show up as the consumption rate. Next slide, we have network fence. Network fence is an API that we provide that a user can use to fence a particular set of IP/CIDR blocks in case of a node loss or a disaster scenario. You can create a network fence class to blocklist the client IP from the complete cluster. Then we have encryption key rotation, which basically is to rotate the keys for the encrypted volumes that you have on a cluster. It rotates the keys at the Ceph level or using Ceph CSI driver. Moving ahead, we have volume/volume group replication operation. Now, these are the set of APIs that one could use to enable disaster recovery or regional RDR in these clusters. Through volume or volume group replication, we provide a set of APIs to enable disable memory mirroring or demoting or promoting the cluster to primary or secondary. For example, we have a primary cluster, and in case of a disaster, the primary cluster is down. Then one can simply switch to the secondary cluster and promote it as a new primary and point all the IOs that are happening on the cluster to the new primary. And once the cluster is back, you can demote it again, the older primary to secondary, and the IO continues. Moving ahead, we have CSA operator. So Ceph CSA operator is a new addition that was recently introduced to manage Ceph CSI CRs or the CSI CRs more granularly. We already had support for CSI in Rook. We still have support for CSI in Rook, but we don't have the granularity to configure each individual driver at the best possible extent. So through Ceph CSA operator, we are providing a set of CRs for each driver, where you can configure each driver individually with different parameters or different requirements that you have for each driver. One can install Ceph CSA operator through Helm charts or YAMLs. So that's about Ceph CSA operator. Moving ahead to the future roadmap of CSA driver. There are a few features like shallow NFS volumes, Kerberos authentication for NFS volumes, NVNIOF, and QoS that are already present in Ceph level. But we have plans in upcoming releases to enable that in Ceph CSI so that users can use, who are using Kubernetes cluster and using Rook to provide a use Ceph cluster, can use Ceph CSI to have those setups in their Kubernetes cluster, and the applications could use that as. Moving ahead, there's a very recent feature that is volume health condition reporter with CSI add-ons. Volume health condition reporter is basically utilizes CSI's node volume get stats RPC to get the latest health of a volume at the storage level and report the same as a set of events on the PVC. So that in case there is anything going wrong, one can observe the events on a PVC and get to know about the latest health status of a volume. Next slide, we have object storage. Nitin will take over from here to describe what exactly object storage is.
Thanks, Nikhil. So, hi everyone, my name is Nitin Goyal. I work as a senior software engineer in IBM. So, I will show you how we can make use of object storage. So, there is a CRD called Ceph Object Store provided by Rook. So, user will be creating this CR with the spec. So, mainly we have two sections in the spec. One is the gateway and another one is a data pool. So, in the gateway, we'll be describing the CRs instances, how many instances do we need for the RGW, and then the data pool we will be describing the storage backend. So here we have described 3 instances, and Rook is gonna act on this CR, and it is gonna deploy the 3 RGW instances, and it is also gonna deploy the backend pools in the Ceph. So in the Ceph object store, there are mainly two parts, front end and there is a back end. In the back end, we will be having data pool and all, and the failure domain zones. And in the front end, we will be having the gateway, the desired instances, and the protocols we can make use of. So we mainly provide the support for 2 protocols. One is the S3 and another one is Swift. So there is another way to do the same thing with the more flexibility. So if we see here, we have a front end. There are 2 Ceph object stores. So in the front end, we will be using the first one for the S3, and the another one we will be using for the Swift. And in the in the S3 we have 3 instances, and for the Swift we have 2 instances. So there will be total 5 instances, and we will be using the same zone for both of them, which is London. So that is how we can also deploy the Ceph object store using the Ceph object zones. So there are 2 ways to provision the volumes. So the first one is similar to PVCs using the object bucket claims and object bucket claim classes. So we will be creating the object bucket claim using the object bucket class, so which is called Rook SC here. And there will be object bucket will be created similar to PV, and we will also have a access key and secret and S3 URL to access it created by the Rook. We also provide a support for the COSI. This is still in alpha. So admin will be creating a bucket class and bucket access class, and user will create a bucket claim and bucket access to provision the volume. And there will be access key and secret and URL all will be created by the Rook to access that. Yep, that is all for me. I'll hand it over to Deepika.
Hello everyone. Now moving forward to more flexible configuration. Short introduction of myself. I am Deepika Upadhyay. I work as a Ceph engineer at Clyso. We're looking into the RGW configuration. Now, most of the questions that I got was how can we configure RGW as based on our needs. So looking into one such scenario, which is like pool placement and storage classes and how to make use of them. So if you see the Ceph object store config here, we have the pool placement as code, and we have a metadata pool, SSD metadata, a data pool HDD data, and data pool HDD single. All three are using different kind of configuration in some way. The first pool has the device class as SSD, as is it hosts metadata, so we want faster access to it. So we host that data into SSD. It has replication 3, so even for metadata there would be 3 copies created. Then the second pool, HDD data, again it will have 3 copies, but it is being hosted into HDD as it is some of the main data. If they are for archival purpose, we do not care much about like being it as fast as SSDs. So we host that kind of data into HDD pool. Third is HDD single. For some cases, we just want to store a copy or two and do not want to expand on using a lot of space for that kind of data. So you can configure that data to be used in HDD single. So how do we actually work with it using S3 command line? So in this case, we are using S3 CMD, but there are other CLI options available for using S3 protocol. So in this case, we create a bucket and we specify the region as cold. And if you see the region, it is the same as the pool placement name specified in the Ceph object store spec. So once the bucket is created, now if we make use of that bucket to put the file.txt, then that file will actually get stored into the HDD data pool. It will have 3 copies, and all the metadata for this file would be stored in SSD meta. And if you want to store other file with reduced redundancy, you just have to specify the storage class that we like created with a second data pool, HDD single. When you specify that, then it will make use of the HDD single pool, and you'll just get 1 copy of the data stored. So this is one such scenario. We have multiple such use cases. For more info, you can reach out to us. We'll cover that in a bit. So another major component of working with like storing your data is the cluster maintenance, the upkeeping of your data and upkeeping of Rook Ceph. So it's not like we can just store the data and forget about it. You have to perform maintenance. You have to take a look into doing the Kubernetes upgrade. You have to look into Rook upgrade and sometimes node downtime as well. So how can we make sure that that is seamless and you do not go into some downtime or you lose data? So that's one scenario. The other is sometimes it's inevitable and there are some outages because of network or any other cases. So can the cluster survive those conditions? So the answer is definitely yes. How? It is because of the topologic awareness of Rook Ceph, and that is crucial to understand how Ceph survives the data and makes it reliable and durable. So in this case, we have three replicas. Three is the default replica that Ceph supports, and we say that the failure domain is zone. So that means that each copy of the data will be spread across different zones. So zone A would have one copy, B and C. So suppose zone A fails, goes down, you still have your cluster fully up. You can do reads and write without any downtime. But what if even zone 2 goes down? Now you only have one copy of the data available. In that case, we do not want to overload the cluster. We want to make sure that the copy is safe. So Ceph will ask that, okay, we do not want to perform IOs. It will go offline. It will ask you to bring back other zones, or at least one zone, so that the IOs can be resumed. So for that, like how Ceph is aware of, Rook Ceph is aware of that. We make use of pod disruption budgets that works on basis of the failure domain that you have specified, and it will ensure that minimum number of nodes or copies or any like resource required would be up while doing node maintenance, and Ceph will make sure of the other part, like going down of failure domains. That's completely topology aware, and that's also taken into consideration while you are doing Rook upgrades. Rook has rolling upgrades, so if you are performing Rook and Ceph upgrades, then there would be no downtime, and generally it's seamless. You just have to monitor the status of the cluster. So yeah, that should be easier now. So now the second case, what if something goes really off? So in that case, we had a customer where during maintenance, they were just performing maintenance and they shut down the node. And after the node came up, they found out that they have accidentally imaged the node. So all their Kubernetes workers, control planes, everything was lost. No Kubernetes cluster existed. But luckily, how Ceph works is it stores the data into Ceph disk, and there are some metadata that you can retrieve. Again, those are manual processes, but you can retrieve those data and spin up the critical Ceph components and extract all the required data from those disks. So even if something goes really wrong, we still have a way to work around it. So that steps are being added to Rook documentation, and anybody, like I think, if they get into such scenarios, we are up for helping them as well. And now looking into the very useful tool for cluster maintenance, or in general, Rook Ceph admin. I would say there is a CLI tool that we use for troubleshooting. It's called kubectl plugin crew, and we have scenarios added into it to make your life easier. You can check out the cluster status. You can check out disaster recovery status. You can do the maintenance and management operations. Run every Ceph command. If something happens to one of the Ceph component and it goes down, which is monitor, responsible for all the connection and maintenance of talking between the Ceph components. So you can also bring it up using this tool. You can remove the OSDs if you want to, and do the MON and OSD maintenance, like advanced tooling. The case we talked about, where we retrieve data manually, that we can do using Crew plugin, and also like restore CRs sometimes if somebody has accidentally marked it for deletion. This is a automation kind of tool, so we are open for feedback into this area, and it's just for making the Rook users' life easier. Now, coming to project health, Rook's community, Rook is, of course, community first, and community is really important to us. We have monthly community meeting. Anybody can join that, and we have major contributors from 4 companies, Clyso, Cybozu, IBM, Red Hat, and Upbound. 500 plus contributors to GitHub projects, many container downloads, and we are CNCF graduated. It's the 5th year now, and where stability is central focus to us. Rook has been declared 6 year stable now since 6 years. There are many upstream users running it in production. You can see them in the link that I added. Many downstream deployments running it in production. Then for the release cycles, we follow the footsteps of Kubernetes. We try to make a release every 4 months. Version 1.17 is already out. 1.18 is coming this month, and we do bi-weekly patch releases. And even if you have some critical need, we also are open to serving them. So these are the website. You can reach out to us on Slack. We are on X as well. And yeah, some of us might have attended the project pavilion. So yeah, we are open for any questions. Any questions? Yeah.
First of all, my thanks to the whole team that maintains Rook and Ceph. I personally use Ceph as well as external Ceph, external Rook. In fact, I use Proxmox, which actually uses the Ceph cluster to hold its VMs. At the same time, my Kubernetes cluster in the form of VMs also uses it for its PVs. So first of all, thank you. Second thing is, 2 things that I have noticed. One is you said RBD can do, driver can do both RWX and RWO. Somehow external Rook at present seems to be doing only RWO and not RWO.
RWO has a file system. As a block, it can do RWS.
I tried that, but it doesn't seem to be working. Maybe I need to try that.
You'll have to take care of the memory safety yourself, like not have concurrent writes to the same location. It depends on the user application that you want with RWX, block mode PVC.
Yeah, see, I understand. If it is block mode, obviously I will have to make sure that it is right one.
Yeah.
Right ones.
Yeah.
But in cases where I require, you are saying I will have to use the file system?
CFFS, RWX, yeah. If you want multiple client access.
Because in this slides I saw, for the RBD, both the RWX and RW.
O as file system is mentioned.
Can you
A few more slides.
can you go back a little? Where you are
Yeah.
see.
Yeah, it's RWX in block mode and RWO as file system. So like we mount the file system on top of the block device. So like the file system sits on top of the block device. Like Ceph is not aware of the file system on top of the block device.
All right. So if I use it in block mode and put my own file system on it, it will still be available as RWX to me, is what you're saying.
At that moment when you like Ceph is not aware of what you put on the block mode. So it's up to you to like maintain the concurrency and access.
I can put any file system, not necessarily I can put.
Yeah, you can use it as you want, but it will be like single client kind of thing. Yeah.
The second question was, sorry if I am getting wrong. I saw you using SSD as a metadata cache, more like where you could specify and relate and say my metadata resides in a faster medium,
Yeah.
right?
Yeah.
But do you do it for caching as well?
Caching at which layer?
Caching at right at the Ceph file system level. Okay.
Oh, you mean like for CFFS?
Yeah. See, if you take ZFS, right, you can do the same thing. Because I have been using in production Ceph for quite some time. In fact, almost more than 2 years plus. So that's why I said first thank you. But can I also use the cache? Suppose I put a couple of NVMEs, which I do for my ZFS. can I use that as a cache?
So when you're configuring Ceph file system, so you can have two kinds of pool. One is data pool and one is metadata pool. For metadata pool, you can configure the device class as.
The fat entries, basically the file allocation table entries.
Oh.
Not necessarily cache. Cache is what data comes from the files. You cache them so that you don't have to go back to that, as long as it is not a dirty read.
Okay, that I'm not aware of. It's probably like CephFS
Like
kernel,
ZFS, if you
kernel
see,
level. Yeah.
You will see there is a separate ZR, and then there is a meta. Meta is the file allocation table.
I think we are not aware of it yet, but it's a CFFS feature, so maybe we can take the feedback and like if
Yeah,
it
I was
is,
only wondering,
Yeah.
only questioning.
Yeah,
If
yeah.
there is one, if there is, you very nicely showcased that.
yeah,
The SSD, the metadata, the
Yeah.
relation between them. It was very beautifully shown. See, metadata pool name SSD meta,
Yeah.
which connects them.
yeah.
Can I do file caching?
File caching, I'm not completely sure
You
because
do that in ZFS.
yeah, there might be like a way to do that in CFFS, but I have to check with CFFS experts
Yeah.
on that.
Kind of. Anyway, that was my question.
No worries.
Thanks, sir. Do you have any other questions?
yeah.
I wanted to know, like, for say NFS, are there any limitations to internet crashes? So for normal NFS, there are experience crashes when your workspace grows. Is it the same for Ceph NFS also?
So the question was how does NFS work with Ceph and what about the availability? Like if the NFS server crashes, like what's the scenarios? So to like do NFS exports over CFFS subvolume, we make use of NFS Ganesha. So there is configurations to make the NFS Ganesha pods run in highly available modes. So you can have like more than one with leader election or some sort of modes. So exactly like how to do that, I'll have to look into it, or you can just check the docs which we have for NFS. But that should be able to do. Like if one of your server caches, the other pod is still alive. So it should automatically be able to route it to that pod for your to serve your requests. So your requests go through the NFS Ganesha server,
Other
and there may be multiple
Um,
servers.
Yeah, a follow-up question also. So MongoDB uses same master-slave type architectures, right? So read goes to your secondaries and write goes to your primaries. So now, so when you're reading your workspace, suppose your secondaries gets overloaded and crash, and your masters also is getting overloaded because when secondaries are not available, then master. Then in that case, you have seen that particular case.
So in that particular case, we have primary OSDs and secondary OSDs. Primary OSDs are where the writes go. The primary OSD itself distributes it in the secondary OSDs. And the reads particularly, I spoke about the read affinity feature. There you can have fine level of controls. Like you can read either from the primary OSD or like balance the reads across or go to the local OSD. So coming to your question, like what if the primary OSD crashes? So automatically something else comes up in its place, and that will become the primary OSD for that particular placement group. So your rights will go there, and then it'll get redistributed.
Oh, adding to that, actually, like Ceph intelligently handles the storage of it. There is no one primary where all the like reads and writes are going. It's all distributed. It would be chosen based on an algorithm which is called Crush. It's a PhD thesis by the creator, and it will intelligently make sure that your data is spread across in such a way that, I think the connection is in such that it's not overloaded just for one instance. So we have few cases, and that's mostly because of network issues that we have seen such bombardment, but not specifically like one thing to be was being targeted or something.
Yeah, I
It's
can
a,
help you in that. There are two methods once again. You can do a pure replication or an erasure coding.
yeah.
So Clyso helps you with erasure coding as well. So definitely that problem does not exist.
Yeah.
There's a network problem as well as the topology that you mentioned.
Yeah.
That definitely affects stuff.
Yeah, and I mean, if it's spread across zones, then there might be network latencies. If it's like the failure domain is host, you might not get like as much resiliency, because if one zone goes down, then you lose all the data. So it's a trade-off in some sense. So like you have to configure and think about what kind of workload you have, and then configure the cluster based on that. It's a game of trade-offs, I'd say. Any other questions? No? Okay. Thank you then.
Okay, thanks a lot, guys.